Okay, so meeting is up. Downloaded malware. Huh? All right. Okay, so looks like this is gonna be the last official workshop, at least of the semester. Yeah, so it looks like we're gonna be covering all of the lane detection stuff from ASME. And yeah, okay, so I'm probably going to be referring to Gonzo a lot during this workshop just because he knows a lot of these commands and things better than me. So be prepared, Gonzo.
Alright, I'll try.
Yeah. Just to mention, for all of the lane detection stuff, Gonzo spent a lot of time watching videos and commenting out like what each line does and things like that. So I'll be going over a lot of the work that he put in. But before that, though, I did promise in the last workshop that I would try to fix my object detection stuff. Um, yeah, so I did promise in the last one that I would try to fix my object detection stuff, and basically what I did was I took another like 30 photos of my. I should probably open this up. Um, if I go over to here, 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 and go into here, basically took another 30 photos of my box here, and I added it into the end. Just like a bunch of photos, basically just from the front, like this, and and I put it into a new folder, and I added in the other pictures as well. And then I spent some time annotating this new one, and just like redoing all of my annotations. And I made this new annotations file, and then I made a new where's it at? Yeah, a new samples file, and then finally a new cascade after that. And one thing I noticed whenever I ran, so basically if I nano computer vision.py, this is the same code that we were using last time. And this is the one that I just put it in to take in the new cascade. It's the same exact thing as last time. And if I do this, so Python computer vision, and I turn off my camera first. So I stop video and I do Python computer vision.py. We open this up. If I bring this over, it still doesn't work, right? And if I tilt it off to the side though, it works, but it works and it's okay. It's like decent, right? So from the side, it works, it's decent. I don't know if it's better or worse than last time. I honestly don't remember how last time was compared to that. But after I did that, one thing I noticed was that all of my JPEGs, whenever I created them, it made this, it put these white bars around them. And what those white bars are doing is it's from the place wherever I downloaded, where I I resized them. So I resized them um, vertical photos all the way down to 256 by 256, and it had an option where instead of just making it 256 by 256, because I would stretch the photo out a little, it puts in like a white, it puts in like white filler space so that it doesn't so that it doesn't end up stretching the photo. And I think whenever I use my camera, it actually, I should probably turn camera back on. There you go. Yeah. Uh, so whenever I use my camera, um, I think it actually stretches the photo out a little bit because it's probably like a horizontal kind of camera. And so I thought maybe that's the reason. And so what I did was I made this new Python file, or this new Python file. I'm still putting in new cascade, and the only thing I added here is this one line right here. That's basically saying resize the frame And I found that a good number was like 0.55. So basically it's resizing the frame to 0.55 of the width. So like about 50% of the width is being compressed down. And so if I do Python, what the heck? How did I do that? There you go. Control Shift Plus apparently zooms in and out. Okay, interesting. Um, anyway, all right. If I do Python new CV and I turn off my camera and I try that again, so now you see like a little compressed version of me, right? But if I bring this up now, you see from a close-up, it's still not very good, right? But we take it farther away. There we go. We got it detecting pretty decently. So if I just move it around a little bit, I'm trying to like point it towards the camera this whole time. So it kind of likes this bottom region around here. It detects it pretty decently. So ended up working decently. I don't have to have it like at this angle every single time I'm trying to detect it. It's actually kind of detecting from the front, and it works pretty well. I kind of like how it came out. It is showing like double boxes sometimes, but that's not my problem. It's working decently. So it's still a little bit rough. It still kind of likes it more from the side like this, I think. Um, and I did have to scale it by 55%, but I'm sure if I put in some more time and like actually went back and got rid of that white space and re-annotated all of it, it would work fine. I just didn't feel like doing all of that. So here's a kind of scuffed but working version. There you go. So that's as promised from last time. Let me turn this camera back on. Make sure that's set up over here. Nice, yeah, okay. Cool. Let me clear this. And I think we can X this out. Okay. You can do object detection on a lot of things. It doesn't have to be a box. Yeah. Okay. So for this next workshop, I'm actually going to be using Visual Studio Code just because Gonzo wants me to. So let me X out all of these. And in here, you basically just go to File, Open Folder, and you like open up your folder, and then all of your code gets shown. And you can actually like click through everything, and you can like see a bunch of codes at the same time as well. They'll all come up here, and you can like go through them, and it's a lot more convenient than Nano is. I'm still going to be using Nano just because I'm used to it, but for this workshop, I'll go through I'll be using Visual Studio Code. But yeah, so we have this test image right here. And at the very end, we'll use a video of this, but for now, we'll be using this test image. Basically, what we'll be doing is we'll be detecting this line right here, as well as this this little line right here, basically. So we'll be detecting this lane, and we'll try to stay in this section, basically. Okay, so let's start off with the very first code. As you can see, there's a lot of comments from Gonzo. Let's see if we can get through this here. X that out. Okay. So obviously, first up, we're going to import our folders, and then he gave like a brief description of what edge detection is. So every pixel Every pixel basically has a value, right? So like a value of 0 means that there's no color, and a value of 255 means that it's completely white. Images are arrays, yeah. Yeah, yeah, so that's actually a good thing to bring up is an image is just like a big array of a bunch of pixels. So like if you have an image that's like 800 by 600, that's just an array of like 800 by 600, and every single one of those things in there has a specific color, and that gets you an
Yeah, you
image,
could
right?
click on the mask array image. It'll show it.
This guy?
Yeah.
Okay, yeah. There you go. Yeah, so like all of these guys have a different color. This is like a bunch of whites and a bunch of blacks, and then that's showing you like where the edges would be is between that change from 0 to 255, right? Those are right for you, Guns, by the way.
All right.
All right, okay, cool. Yeah, yeah, so basically just saying that like a sharp change from black to white would be an example of like of an edge, basically. Yeah, and then to get started though, obviously first line, we've been through a lot of this stuff so far. So like the first line here is reading this image and putting it into image. And then this line we haven't done. Basically, it's just making a copy of the image so that we don't mess with the original. So like we're gonna be doing some stuff to the copy, and this is just like don't mess with the original. Let's just make a copy. Gonzo says it's good practice. Personally, I don't. It doesn't really matter for me, but I'll do it just because he's here. Um, so so we're gonna be making this new image called lane image, and it's gonna be a copy of the original image. Okay. And then obviously, just like we usually do, we're gonna grayscale it. So take lane image and gray, make it gray. And then this one is new here. This is applying a Gaussian blur. And basically, if you look at this photo, like this test image, there's a lot of very sharp edges to it. So like here, like for this tree, for example, you can see that like, there's an edge there, an edge there, an edge there. There's like a bunch of little edges in the tree. And what this Gaussian blur is basically going to do is it's going to kind of blur the image a tiny bit. So this 5 comma 5 basically says go 5 pixels by 5 pixels. So go through the entire frame 5 pixels by 5 pixels and just make a bit of a blur at every single set of like five by five. And that's all that line really does. So yeah, here, by the way, I should probably go over this is an example right here is where you have, this is like white, 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 white. So you have like this huge surrounding white area, and inside of it you have this number 90, which is kind of like a little bit, it's close to black, let's say. So you have a bunch of white and then the random black dot in the middle. What this Gaussian blur is going to do is it's going to see that there's a bunch of white, and it's going to kind of take the average of all of it and add that into this middle number. So this middle number gets converted and kind of like shifted and basically gets blurred, so it mixes in with the other ones. Change the 5 to a 10 and we fix all the vibration problems. It's not a bad idea. We could, yeah. Okay, yeah. Yeah, so that's all there was for that. 5 by 5 is the size of the kernel. I mentioned that already. And finally, the only other thing we were going to be covering is the canny, and I believe we did this in the last workshop as well. I explained like you give it the image, right? So in this case, we had our original image. We made a lane image as a copy. We took lane image and we made it gray. And we took gray and we made it blur. And now we're taking blur and we're making it canny. So canny is the one where it detects changes in like in these colors intensity. So like changes from this white to this black, and it'll go through and it'll either make everything black or it'll make everything white. And just to show you guys what that kind of is doing, um, basically these next 4 lines is just showing all 4 of those images, and then if I press something, delete all of them. And if we go here and we run this, let's see here. So first we have our original, right? This is the original photo. And then we have our grayscale. So original photo, grayscale, they're the same, just one is gray. And I'm gonna X the other one out. So now we have grayscale. And then blur. And if you look at something like the tree, for example, you can see in this one it's sharp, and this one it's a little bit blurred, and that'll help out a lot in this canny detection stuff. And so now if I X out the grayscale one and I bring up the blur and I compare it to canny, you can see it detected like there was a change from gray to white over here. There was a change from gray to black over here, and it detected like a bunch of this stuff. And it also even detected this tree, right? And in the tree, you can see even with the blur, it still managed to detect that little leaf, the missing like section of leaves there, where it goes into the tree. So we might even need to put a slightly larger blur on this just to get rid of that as well. But we're not going to worry about that for now. For now, this amount of blur is going to be fine for us. And this was the final result of all of this. So we got through all of that, and we were able to get the canny version of it as well. Was there anything else you wanted to mention, Gonzo, or is that good for the first part of this?
That's not good for the first part.
Okay. There's 4 parts to this. That was the first. We're going to move on to the second. Each one is basically just going to be adding in a little bit on top of the last part, basically.
Yeah.
So like if I open this up, you can see now we have, we basically added in this one line at the top, import matplotlib. And if you don't have this, whenever you, I should probably, whatever, do that, okay. If you don't have this one line, whenever you try to run it, it'll tell you you don't have it. And then you can just do pip install and just write whatever it told you you don't have. So if it tells you like you don't have, was it matplotlib, I think is the name.
Yeah.
So if it tells you you don't have that, then why does this thing keep coming back? There you go. Then you can just type matplotlib. I'm not sure if this is the official name for downloading it, but whatever it tells you, just put that into here, and that's how you get it. That's all you really have to do to get it. Yeah. Okay, so that's that. And then these are just some definitions. I'm gonna actually minimize this. This is another cool thing about Visual Studio Code I learned the other day. You can minimize functions. And we're gonna come down to here. So first thing we're doing is we're reading the image again. We're putting that into image. We're copying the image and we're putting that into lane image. Take lane image, make it canny, and set that equal to canny. So this is all like basically the same things that we did last time, just this time we didn't put the blur on it. But that's it. So we're just doing the same thing as the last code. We're just making it canny, and we're naming it canny. Oh, wait, hold up. Sorry. I almost skipped something. So this canny, this isn't the CV2 version of it. We actually defined that function up here. So if I open this up, I'm saying this object, canny, is basically it's going to run this canny function and it's going to give it the image. So it's going to give it this lane image. And so you put that up into here. And then what this function is doing is it's taking in an image. In this case, it's taking in a lane image and it's making it gray. It's doing the blur and it's doing canny. So it's actually doing 3 things all in one line. So you just write canny is equal to canny of this image, and it's going to run all 3 of those things. And then the last one is set equal to canny, and it returns canny. I know we use canny, the word canny a lot, but that's just how we did it. So it's going to return that photo after it runs the grayscale, the blur, and the canny, and we're going to set that equal to this right here. So that's running this function right there. And then after that, we can scroll down a little bit. The next line is cropped image, and we're going to be running region of interest of canny. So we're going to be running this function here, region of interest, and it wants an image, and the image we're going to give it is the canny image. So if you guys remember, canny was the one that had, I could probably open this up. Canny is the one that had like those white lines on it, right? Sure, this one. So canny is this one right here that had a bunch of white lines everywhere. And so if we go back to part 2, we're going to be passing that into this. And image.shape0 is just the height of an image. So like how many pixels of height does this image have? If you wanted the width of an image, you could go shape 1, and that gives you the width, but we're interested in the height, so we're using 0. And then this next line here, polygons. Basically what this is doing is it's making a triangle. So if I open up, should I run it, Gonzo, or can I see pixels? Let me see here. Can I see
Just do
pixels
test.
from here? No,
No,
I
you
can't.
can.
So I'll probably have to run it, huh?
Yeah.
Okay, let me run this. I'll close all that and
We should have kept that one.
shit here. Okay, hold up. Let me run this again. Oh no. Okay, hold on. Okay. Let me close. Can't do anything right today. There we go. Okay.
Yeah, so this is the matplotlib library, which
Yeah.
allows you to display images with the XY axis on it.
Yeah, and here we have X and Y. So Y is from the top left, just to keep that in mind. So like the origin is actually up here, not down here. Yeah, so this array thing right here, this polygons, is basically it's making a triangle at 200 comma. So the first point of the triangle is at 200 comma height. And so 200 and the X is here. And the height of it is 700 pixels, right? And so you would think 700 is up here, but it's actually down here. So this right here would be the first point. So 200 comma 700 right here is the first point. And then the next point is 1100 comma 700. So right over here. So we have this point here and this point here. And then the final point is 550. So right about here, comma 250. So 250 is right about here. So if we draw this triangle, it'll kind of be from here to here to here, back to here. And then this area here. This is basically like the region that we're interested in. So region of interest. And we're basically telling it that this line here and this line here, these lines are the ones we're interested in. And so these are the ones we want to focus on, ignore all of the other ones. But code-wise, this is just telling it that these are 3 numbers. To actually use that, let me close these. Okay. To actually use that though, we have this line right here. Mask is equal to numpy dot zeros like image. And what this line does is it takes the image. So it takes our image, the original one that we're giving it, not the original, this canny one that we gave it. It's taking in that image, but it's just taking that height and the width, and it's making a black photo. So zeros like is just the command that that returns a bunch of zeros, right? So and 0 in our case is black. So if you had like I don't know, another command like ones like, for example, or 255s like, it would return an array of a bunch of 255. So that would be like a full white image. But in this case, This is just making an image that's completely black. And then over here, we're telling it that we have this black image and we want to draw this polygon in the image. And 255 means draw it as a white color, right? So basically, give it the black image, take this polygon that we made, which is a triangle in our case. So take this triangle, and then cv2.fillPoly is one of OpenCV's commands, where you can draw any like polygon onto an image, and in this case, it's a triangle. So draw this triangle on this black image and make it white. And then finally, down here, we're finally going to get to the last step of this is take in this black image. Okay, hold on. Let me go back one step. This line right here, this is kind of the same as saying mask is equal to this. So cv2.fillPoly, it's actually changing the mask photo.
Yeah.
So it's taking in that black image and it's adding in this triangle to that black image. So now we just have a black image and there's a white triangle in the area we're interested in, right?
Mm-hmm.
And then finally down here, we take in that image with the region of interest. So we take in the black image with that triangle, and we also give it the canny image.
Yeah. I could kind of explain what the bitwise and
Sure.
operator does. So what it does is that it returns 1 at every pixel where the canny image and the mask image are set to 1. If they're not, then it just sets it to 0. That's basically what that's doing.
Yeah, and to kind of show that, if I open up the canny image, everywhere where it's black, you have 0. And everywhere where it's white, you have 1. And the region of interest part basically said that everything else is black, and the area from here to here to here, so this triangle area is white. So this little area right here is white and everything else is black. And so what we're doing with this bitwise command over here, I can't move it out of that. Whoops. What we're doing with this bitwise and command is we're saying everywhere where this image is white and that triangle image is white, that's your new that's the new thing that just set that to white and set everything else to black. So like in this case, this area here is black, but in the triangle that would be white.
Yeah. You can show it on
And
the mask canny picture.
okay, yeah. So you end up with this. So this one becomes this. So in the other photo, this area is all white, and in this photo, this area is black. And whenever you do an AND operator, 1 and 0 is 0. So if you combine white and black, you get black. So in this masked canny, this final one, this black area stays black. And the white areas in here stayed white. And that's basically all there is to that. Because like this area over here, it's white, but in the other photo, it's black. So then it stays black. So that basically only the white areas stay white, and that's how this final photo ends up. And we'll show you that in a second here as well. So that's our final like masked image. Does that make sense so far? I don't know if I'm explaining that very well.
Yeah, sounds good.
Everything else is good? Okay. Okay. I'm gonna actually minimize this canny and this region of interest. So just keep in mind this masked canny thing with these lines and everything like this. This is the final product of region of interest. And so that's the final product of this. So cropped image is our new, cropped image is basically this photo right here. And we're not done just yet. We still have a little bit more to do. This line right here, this is basically the definition of what a line is. So you're telling it that the line has to be at least 40 pixels long. It has to have at least a gap of like 5 between it and another line, I believe. Or between it and another line, there has to be a gap of less than 5. I think I should probably say it like that. And then you have to give it this empty array and these random numbers in here. You just give it to it. I was told not to worry about these and just write them down. Gonzo, I don't know if you have a better explanation for any of those numbers.
Yeah, a lot of this is what Aaron said was like defining what we specify as a line. There's a lot of like math that goes involved with this. I can link the video. The guy talks about it for like 30 minutes just on this one line. Um, but we won't worry about that. Yeah, he talks about y equals mx plus b and stuff, and how translating that into like the Hugh space or the however Aaron pronounces it.
Hugh, you got it right.
Yeah, the Hugh space.
Yeah, the guy pronounces it like Huff.
Yeah, the Huff
For me, this
space.
just says Hugh. I don't. You guys can argue about that. I think it's Hugh. Yeah, but that's basically it. It's just saying that a line. Huff. No. Yeah, so it's just saying that a line is basically this definition right here. So all of these things is saying what a line is. And then we're also giving it the cropped image. So we're giving it this cropped image here. And what it's doing is it's returning everywhere where it saw a line. So it's looking at this image and it's looking at its definition of what a line is. And then it's saying, okay, well, this kind of fits the definition of a line. This one here kind of fits the definition of a line. And these both fit definitions of a line. And it's just returning those. And it's like it's deleting these guys over here, basically. And then we have this one final line, almost final line, that's basically saying that you want to take the lane image. So this was the canny image that we had. Oh, no, sorry. This is the original copy that we made. So over here at the very beginning, we made a copy of the image, right? And we named it lane image. And then we did some stuff to that. So like we took the lane image and we made it canny. We put that here, and then we made it gray and did a bunch of stuff like that. But we never actually changed the original one. So what this is doing is it's taking that original image basically, and it's taking the lines, and it's running this function here. And let's see what that does. So it takes in an image and it takes in lines. So we know where the lines are now with a few lines that we're interested in. And we have our original image. And this is basically saying from that original image, make a black photo. So same thing as before, take the image and make a black photo. And if lines is not none, is basically saying if there is a line. So if lines is not none is if there is a line. So if we did detect a line, then for every line in that set of lines, because we can detect multiple lines, right? So for every line in there, line dot reshape for x1, y1, x2, y2 is just a function that takes the coordinates of the line. So line dot reshape for takes in the 4 coordinates. So x1 and y1 is the bottom corner, and x2 and y2 is like the top corner. So take in those two numbers. And then cv2.line is another one of the cv2 functions, OpenCV functions, where you give it the image So I'm giving it this new black image, right? Because we made it black. So line image is a black image. And then draw a line. It starts at x1, y1, and it ends at x2, y2. BGR, so the color is blue, and it has a width of 10. So 10 pixels thick. So it's a 10 pixels thick. The color is blue. It starts at x1, y1. It ends at x2, y2. And do this for every single line that we detected with this lines function. And then finally, that just returns that black image with those blue lines on it. And then over here, we're showing the cropped image. So we're showing the canny one with the region of interest. We're showing this line image, which has I missed one line, but I'll go back to it. So we're showing the cropped image, which was the black photo with just the region of interest and like those black lines on it. I mean, the white lines from canny on it. Um, so this one basically. So we took this one and we made it into this, and that is our cropped image. And then line image is the one that we just made, where it's a black photo right here with the blue lines on it. And then combo image is this last line that OpenCV basically has a command where you give it two photos and it'll put one photo on top of the other. So I'm giving it lane image. So my original copy over here, my original image over here, I'm giving it that image. And then at 80%, is it not, what's the word I'm looking for?
Transparency.
There you go. At 80% transparency, put this line image on top of it. And then 1 comma 1 is just something you have to add to the end. Don't worry about that. Just throw that in there. But yeah, so it's basically taking in that original image and it's taking in my black image with the blue lines, and it's just adding this one on top of that one at like 80%, whatever Gonzo just said.
Transparency.
Transparency. I don't know how I always forget that word, yeah. Yeah, and then this last line here is just something from MATLAB, Matplotlib, where you can like plot the image and it'll show the axes like Gonzo mentioned before. And finally, if we run this, we have a bunch of things that come out. So originally over here, we have the canny photo. We had the canny photo from last time. And this is what happens when you combine the canny photo with that region of interest. So you get this region of interest edge detection kind of thing. And if I move this over to the side, from there, we had this. And this is the one that took the lines on a black photo and added it in as blue lines. And this is like with the definition of a line. So it detected that this is a line, this is a line, this is a line. So it detected all of this stuff as lines. And on the other side, it detected that this whole thing here is a line and this thing here is also a line. And it got rid of all of this like extra waste stuff over here. So they can get rid of that one. So now we have this. We have this kind of like blue lines on a black photo. And then we have the combo one where we took the original photo and at 80% transparency, we added in those blue lines on top of the original. So it's just adding this on top of this. And then obviously like this last one is just making a plot. This isn't really super useful except for seeing the pixel numbers. Yeah, so I can close this. Does this look good so far?
Yeah.
Okay, sounds good. Yeah, okay, sounds good. So then this part two is basically like looking into these lines, right? Part one was just manipulating the photo a little bit. Part two is getting these lines and basically detecting and saying like what a line is. In the next part, we're gonna kind of like try to
Optimize.
combine these lines. Is there a reason why the area of interest is essentially set to the focal point of the image, or is that just coincidence? No, so that was on purpose. So this guy, his video, obviously, like we can't really use this for ASME's purpose because our lines could be in a lot of different places, and our lines are curved, right? So this is just like a good way to get an understanding of how it works. And then from here, you can build on it and you can say, okay, maybe I can define what a curve is. Maybe I can do this or that. But for this guy, he just knew that his area of interest was here. So he just made this his area of interest. For us, if we can assume that the lines will always be in a certain place, we could do this as well. But it might not, like we could probably cut off like the top half of the photo because that would be the sky, right? But other than that, it might not be a good idea to just preset what your area of interest is.
Yeah, and a lot of times, like, you don't really want, like, there's no real reason to detect all those lines out there. You kind of only want, like, the very few that are right in front of you.
Yeah,
Like,
so
there's
like
no,
basically like this area, right?
yeah, and that's what part three is about, like, optimizing these lines to where, like, you see how, like, you could tell that there's multiple lines in there? It's like, like, on the left one, there's two that you could see. The right one, there's, like, four or six. And part three is just optimizing it by taking, like, the average of slopes and stuff. He'll cover it right now.
Yeah, so that's what I was about to say was part three is basically what Gonzo just said is since there's a bunch of lines here, we want to try to convert this to one solid line, and same with over here, just one solid line, and then part four will basically be doing all of that onto a video, and part four is very simple, so we just have to get through part three now. So
Yeah.
I'll close all of that. Okay, hopefully video is showing and everything. Yeah, so that was part two, and now let me open up part three. So canny, we already said, right? It takes the image and makes it gray and adds the blur and makes it canny and returns that. So I'm going to minimize this. Region of interest is still the exact same. It's taking the height and it's drawing that region of interest like white triangle around the area it's interested in. And, oh, oops, I meant to close this one. And display lines is still doing the same thing. It's taking your definition of a line and it's drawing those lines, those like multiple lines in the places where it detected a line. So I'm going to close this one as well. So now we have two new functions right here, and I'll go over them from the bottom. So we'll go over it like code-wise. So down here, we're taking in the image. We're doing the same exact thing as last time. So everything up to here is the exact same. Take in the image, make a copy of it, run the canny stuff on it, get the region of interest one, and then finally return the one, return the lines basically. So take this one, yeah. So take this photo and return where we see all the lines. But now, before we draw the lines, we're actually gonna have one extra step in here. So, where did it go? There we go. Can I only have two open at once? Whatever.
I think if you double click, they'll open up as tabs. Yeah, we can do that.
Am I blind?
No, like double click on it. Like,
Double click. Oh, there you go. Okay. Okay, sure. Thank you. Wait, I didn't even open the right one. Okay, there you go. Okay. Okay. So let's get back to right here. So this line is same thing as last time. We're detecting where we see a bunch of lines. So it's the whoopsies. Let's go back over here. So we're detecting a bunch of those blue lines, right? But before we draw it, we're going to go through this line right here. This is calling a function named average slope intercept, and we define that right here. And average slope intercept takes in the lane image. So this original copy, it takes in that original copy, and it takes in the lines. So it takes in the original copy and the lines that we detected, and let's see what it does with it. So it takes them in as an image and the lines, and then it starts up these two arrays named left fit and right fit. And this is just starting up, telling it that it's an array, just how you start up at arrays in Python. And then for every line in the lines, this should look familiar. At least this line should look familiar. Is we're taking the x1 and y1 at the bottom point, and the x2 and y2 at the top point, and we're putting that all into these four numbers here. This is for every line that we detect. Do this, and then this line here, numpy.polyfit. Sorry, I forget. Which one was polyfit, Gonzo?
Polyfit, so if it's a polynomial of degrees from the points.
Why am I forgetting this line? Oh, this just gets the slope of the line, right?
Yeah. The
Okay, yeah, there you
degrees.
go. Okay, yeah, I was so confused for a second there. Okay. Yeah, so basically you give it x1, x2, and y1, y2, and it runs its calculation, and the first number that it prints out, so the zero, so in arrays, zero is the first number. The first number that it prints out is the slope, and the second number that it prints out is the y-intercept. Look, my video froze for a second. Am I here?
Yeah, you're good.
All right. Yeah, so the first number is the slope, and the second number is the y-intercept. So kind of like y equals mx plus b, it gives you those numbers. And then basically we're saying in here, just,
We're defining the left side of
yeah,
the left side of the lane and the right side. So like the left side of the lanes are their slopes are negative because they're like the way they're pointing, and like that's a negative slope, and the other one's positive.
um, yeah, I think it's backwards here, right? Yeah, because
Yeah, because they flip it
it's
and
flipped, right? Yeah.
yeah.
So the image is flipped. So this would normally be positive and this would be negative, but in this case it's flipped. So this is negative, this is positive. Yeah, so if it's negative, add it to the left, and if it's positive, add it to the right. And then this next line, so that's taking the slope and the intercept, right? So then this next line here is saying take all of the numbers in left fit, take all of the numbers that we added, so take all of the lines that we just added, and return the average of all those numbers. So we're told it like we have a slope right here, we have a slope right here, a slope here, and it intercepts over here, 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 and same thing with the right side. And it's basically taking all of those numbers and it's just going to return the average number that it sees. So the average slope and the average intercept, and then the average slope and the average intercept for the right side as well. And then right here we just have a line that prints that out. So print out the average slope and intercept. And then finally, right here, the last part of this is this make coordinates function. So we're going to give it the image, the original image, and we're also going to give it the left fit average. So we're going to give it the slope, the average slope, and the average y-intercept. So we're going to give it those three things, I guess. It's two, but the second one is two things. And we're going to run this make coordinates. And what make coordinates is up here. So you're going to give it image and line parameters. So in this case, left fit average is line parameters. And in the next case, right fit average is going to be line parameters. And what it's doing is it's saying that slope and intercept is equal to the two numbers in here. Y1 is equal to the height of the image. So if I opened up, I can't open it up, but if I opened up like the plot, maybe I could run it. Maybe I should run the second one. How about this? So if I run this and I close all of these, it's weird. My close button isn't working again. That's really weird.
It's the plus
Oh,
sign,
that's the
right?
graph. Yeah, you're right. Okay. Yeah. Okay. Let me minimize these for now then. So where did my part 3 go? Okay. So my y1 is the height. So y1 is this 700. Y2 is y1 times 3/5. So y2 is 3/5 of 700. 3/5 of 700 is about like 500-ish, right? So somewhere between like 4 and 500. So your y2 is going to be around 4 and 500. So like right about here. So this is y1 down here, and this is y2 like up here. And then my x1, so you know how you have y equals mx plus b? Well, we have y, we have m, and we have b. We have the y value, we have the slope, and we have the intercept. So with all of those three, you can calculate x1 and you can calculate x2. So put all of that together, we have x1, we have x1, y1 down here, and we have x2, y2 up here. And then with the right-hand side, we'll have x1, y1 down here, and we'll have x2, y2 up here. And then this is just returning an array of those four numbers of x1, y1, and x2, y2. So the final lines that it detected. So that's what, so this is going to return x1, y1, x2, y2 to over here. That's returning it to left line. And then it's also going to return one of those for right line. And then this function, this average slope intercept, is going to return back to the very original code. And it's going to return the left average line and the right average line. So all of that just to get, basically all of that was this one line. All of that was to get averaged lines. And then now, just like last time, we give display line. That was the one, if I minimize this and this, display line is this one. That's the one that just said if there's a line, draw a line, right?
Yeah.
So display image, sorry, I give it my image and I give it the average line, and it's going to draw that average line on the image. And then same thing as last time, we're also going to make a combo image that takes that original photo and adds this line to it at 80%, at 80%
Transparency.
transparency. Thank you. I'll try to remember. 80% transparency. And then just show all those images and wait until we press Q. And the plot is down here too. If you want to uncomment this, you can. It's a little bit annoying because you have to, the way we have it coded at least, you have to press Q on the plot before you can press Q on the image. But it doesn't
Yeah,
really
the whole
matter.
point of the plot is just to see or to mark down your region of interest.
Yeah, to see like the pixel
Yeah.
numbers basically. Yeah, so we have our original mask, right? Wait, am I running the right code? Yeah,
Yeah.
I am. Okay. Yeah, so we have the original mask. And then this time we have averaged lines. So if you remember from last time, we had like a bunch of different lines showing. This time it's just one average line. And from last time, you might have noticed it went kind of farther, right? So it might have went like up to here. This time, it's only going to 3/5 of the height. So the height here is like 700, right? And it's only going up to about 410, 420, 420, perfect. Yeah, so it's only going up to like 420. So if I close this and put this over here, so then all of that was just to get this two averaged lines. And then finally, we put those lines onto the original photo. And that's really all there is to that. You get your average lines and you throw that onto your original photo. And really that's it. The next code is just running all of this on a video. And if you remember from the OpenCV stuff that we did before, it's just like a couple simple lines. So let's see here. So now we know canny, we know region of interest, we know display line, make coordinates, and average slope intercept. We come over here, canny, region of interest, display line, make coordinates, average slope intercept. So those five are all the exact same. And now we're just adding in the video part. So you guys will probably be able to do this yourselves as well. But basically we're saying that test2.mp4 is this video I have here. And it's just a video of those lines going by. We're putting that video into this cap, into this variable named cap. And while cap is open, so while there is a video, return the frame basically. So this was, I believe whenever I usually do this, I name it like return, right? Like return comma frame, I think is how I usually do this, but it doesn't matter what you name this because we're not going to be using it, so you could just use an underscore. Yeah, so then we're just reading from cap or from the video, read a frame into frame. So read every frame into frame and then run the canny stuff on it. So we get the canny image, run the region of interest on the canny image. So we get the cropped image. So we only get that little area of interest that we're looking at. And then from the definition of a line, look at the cropped image and return where we see all the lines. Take those lines and the frame and give me my average slope, and that'll be averaged lines. Put average lines onto, using the display line function, take average lines and put that onto the frame. So that'll be the lined image, right? So take those average lines and put it onto the frame, and that'll be your line image. And then finally, we have the last line, which is that add weighted, which takes the original frame and it takes the line image that we just made, and it puts this onto that with 80% transparency. There you go, I got the word this time. It puts this onto that with 80% transparency, and finally, just show the final image. And if I press Q, break. And now this was all the same. The only new part was this, like 3 lines up here, where we're adding in the video. And so if I press run, we now have a video of it detecting the lines. And yeah, if I go back to part 3, by the way, I don't know if this is blocking the thing. I'll put it up there. If I clear all that and I run part 3, you can see whenever, one thing I forgot to mention was in this function here, yeah, in this function right here, it's printing out the average left line and the average right line. So the left line it's saying is this slope and this y-intercept. So if I go back to like this, Maybe I should add in the MATLAB plot for this example. So let me just show you guys this real quick, and I'll go back to the video one. If I press run, and I close this and this, and I bring this guy over, we're printing out from this guy right here, the average left line and average right line. And if I go back to here and here, in the terminal, you see negative 1.6. So the slope of this guy here is negative 1.6. Or in our case, you could say positive 1.6. And then you can see over here that if this kept going, it would come down to right about here. And the y-intercept here is about 1200. So it starts at 0 and it comes down 100, 200, 300, all the way down to here, which is right about 1200. And then the next line, the right line right here, you can see it's going like this. It has a slope of 1.02, which in our case is like negative 1.02. And it goes and goes and goes and goes. And if it kept going like this, it would intercept the y-axis, or it would intercept basically x equals 0. The y value would be negative 300. So from 0 to negative 100, negative 200, negative 300 up here. That's just pointing out. I just thought it might be interesting if you guys wanted to see it is printing that out. And if I go back over here and I press run, if you watch the terminal, it's actually printing out, constantly printing out the slope and the intercept. And yeah, that's just about that. That's just about everything. One thing to mention, what I was gonna say, was on like the Ross side of this stuff, that would be a great thing if you guys could print out. So like for the computer vision team, if they were able to print out like the slope of the line and maybe like the distance to the line or anything like that, that would be great for us because then we would be able to align ourselves, right? So like if it told us like the left line is 50 pixels farther than the right line, okay, maybe we need to move over to the left. And if it told us, okay, the slope of the left line is 2 and the slope of the right line is 1, then we need to turn a bit to the right or something, anything along those lines. Like we want to align ourselves with this, we want to do this. So these are just some of the things that the computer vision team can print out. And so just while working on code, that's just something to keep in mind is what can you print out to the state machine people so that they're able to use that information somehow. Yeah, I think that's everything. Gonzo, did you have anything to mention? I'm gonna just keep running the video while you talk.
Yeah, I think this kind of shows a great example of kind of like mathematically how it all works. I think in terms of computer vision, there's not much machine learning involved in this. There's a little, but I know the ASME robot has a TX2, which has a graphics card, which would be beautiful to use with computer vision. And maybe if we could work on both this and a more machine learning oriented approach. I think that'll be a good plan to have.
Yeah, probably combining this and that. And
Yeah.
I also heard the other day that for the ASME competition, it's not only lines that you have to detect, you also have to detect potholes. And apparently, like they paint the potholes like white or something so that you can detect them easier. So that was a little bit interesting. So it looks like ASME is actually going to be combining object detection with lane detection at the same time. So it's good that we have a TX2.
Yeah.
Yeah, I think that's everything, right?
Yep.
Yeah, I think this will be the last run of the video. And if there's no questions, sounds like a plan. Okay, good. If there's no questions, then I can just end the recording as well.
Last workshop of the semester.
Yeah.
Oh,
Yes, sir.
Thanks,
oh no, we still
everybody.
have Yolan. We still have Yolan next week. Fuck.
Last software workshop.
Oh yeah, last software.
A lot of
But yeah,
stress is gone. Yeah.
no, you did good, man. The whole semester, so
Yeah.
something to be proud of.
There's probably some more stuff to go over, like controls codes and little things here and there, like how to combine Arduino and ROS and stuff like that. But I don't know. Maybe I'll do that next semester. Maybe I just won't make a video and we'll just teach it to the few people in the actual club.
Yeah,
We'll
I
figure
mean,
that
however
out.
you feel like is necessary. I think you could do those like in your meeting time though, or like
Yeah,
just create a video yourself, pretty much.
yeah, probably. But yeah, that's for this semester for sure. That's the last official workshop.
It is.
Yeah,
I
okay.
mean,
So I'll
it was
stop
good.
sharing and I'll also stop the recording.
Bro, take it easy, everybody. Thank you for coming.
All right, see you guys.
Later,
Peace.
boys.